This video we will focus on how to find the slope-intercept form of a line, which is in the form of y equals mx plus b. While there are other forms of a line, this is the most common one we use, especially at the beginning of our algebra work, because we try to focus on the actual graph of your line, and the easiest way to do that is to be able to look at for the y-intercept and also to talk about the slope. So the y-intercept is going to be where it crosses your y-axis, which is going to be at the point 0b. In this particular scenario, that is a y-intercept of 2. But all y-intercepts will be in the form of a 0b, which is the point at which your line crosses the y-axis. The other important part of your line is the slope. That is going to be m, not the x. The x is a variable which is always there. The m, which is the value in front of the x, is your slope. And there are several ways to think about slope. As you're looking at your graph, you can see here that we have 2 points that are in red that are plotted on this line. And you can see that we have a rise and the run. And so that's the most common way to start talking about slope, which is the amount your graph goes up. So that's the rise from one point to the next. And then the amount your graph goes to the right or left, so the run. And there's also what we call the change in y over the change in x. And then there is also the delta y and the delta x, where delta is the scientific symbol for the change in. So all of these represent this growth of your line over as x changes. So you have the rise and the run, which you find in your slope. That goes in for the m, and where it crosses the y-axis is the b. So let's look at a couple ways of doing these examples. One way you have to be able to find the equation line is from a graph. And so you need to figure out what your slope and your y-intercept is. And from your graph, you can kind of see one of these really quickly. That would be the y-intercept. So we'll write that down as something that is equal to b, where b is equal to 2 because it intersects the y-axis at the point 0, 2. And then we need to figure out what our slope is equal to. So our slope is going to equal the rise over the run between any 2 points. It doesn't matter which 2 points you choose, but what you want to draw in or think about is what we call a slope triangle, where you draw in your rise, and then you also draw in your run. And as we look, it looks like between our 2 points, our graph goes up a total of 3 units, and the run is a total of 4 units. Now it does go up and to the right, so notice that this graph has a positive slope because all positive slope graphs go up and to the right. So that'd be a positive 3 over 4. And that's how we could write out what our slope is equal to, because we have our rise of 3, and that is over our run of 4. From there, you've got pretty much everything you need in order to write your equation line. You got your m and your b. So y would equal 3/4 x plus 2. And that would be your equation for this line. Next, we will look at how to find an equation from a table. So the first thing to notice is that as you look at this table, that the y values go up by the same amount every single time for every same change in x. So not every single table is going to be set up where you have the x values go up by a constant amount, but this example is, and that is important to notice that the y values go up by the same amount every single time. Looking at how the table changes is important for us to figure out what the slope of this equation is. So as we take a look at our y values, it looks like they go up by the same amount every single time. So if you do 6 minus 4.5, that's 1.5, and that's how much your y values are going up every single time for each of our table points. And as you also have to take a look at your x values, that's important because that is our change in x, and those go up by 1 every single time. And that would help us figure out what our slope is, because we now have our rise over run, which tells us that our slope is equal to 1.5. Now we have to think about our y-intercept. That is going to be the b, that is the y-intercept, which of course is where x is equal to 0 in our table, and it looks like that is the point of 0, 6. So our equation is pretty much set now. We have our slope, we have our y-intercept, and our equation of our line is 1.5x plus 6. Now we get into the point where we have to start actually using the algebraic formula to figure out what the equation of the line is. So here we are given a slope and a point. Now it could be given just in words, where it's just given in a statement, or it could be given in a graph where you're given a point here and the slope is told to you somehow. So this is a negative slope. The slope is going down. So you can see that that makes sense that it's a negative 2/5. So what we're going to use this equation, the y equals mx plus b, in order to help us do it. So just out of practice, I'm going to start by writing my y equals mx plus b equation. And now I'm going to take a look and know what my slope is. And to know that my slope is equal to negative 2/5, so that is what m is. So I'm going to rewrite this equation where instead of putting an m, you have a negative 2/5. So you just have a negative 2/5 x plus b. Our final goal is to figure out what b is. I mean, that's really it, because you're told the m in your equation, and you just need to figure out the b. So we're going to use the slope to do that. We plug that in at negative 2/5, and now we're going to take this other coordinate point that we're given, which is 5, 4, and we're going to plug that in, because that is a coordinate point of x, y. So 5 is going to go in for x, and 4 is going to go in for y in your equation. So you still have the negative 2/5 out front, and you still have the plus b you're trying to solve for. And now it's just solving this equation for b. You have to multiply the 5 times a negative 2/5, which is going to be a negative 2 because those 5's cancel each other out. This is a 4 plus b, 4 on the left side, and you still have the plus b, so that means that b is equal to 6. And our equation for this line is y equals negative 2/5 x plus 6. So for these equations or problems where you're given the point and a slope to figure out the equation, you plug that slope right into your formula where it says m, you take your point, plug it in for x and y, and you solve for b algebraically. The final part of finding the equation of a line is to be able to find it from 2 points. So this uses the most amount of algebra and kind of puts everything together conceptually and algebraically that we've done so far. We have 2 points on a line, and we're trying to figure out what the equation of it is. We can see that the slope of this is a positive, so that should make sense as we come through all of our work. So what we need to start with is to start it with that slope, because we want to find the slope between these 2 points. And in order to do that, we're going to think about the change in y over change in x. Thus, as we look at our coordinate points, we're going to think of our first coordinate point as x1, y1, because that's one point, x and y. And we're going to think about our second point as x2, y2, because that's our second point, x, y. So in order to calculate our slope, what we're going to do is use change in y over change in x concept, and we're going to write out the formula y2 minus y1 all over x2 minus x1. And that's how you can find the change in something, is to make sure you subtract. That subtraction difference aspect of it is really important for you to find your slope correctly, and it's a spot where a lot of students tend to make mistakes. So let's calculate our slope right now. So we're going to start with our y2, which is equal to 1, and we're going to subtract our y1, which is equal to negative 5. Notice I have my y values in green, and then the negative, because that's always there, in black. So you can see these are 2 different y values, and you are subtracting them. That's important, and that's all going to be over x2, which is 6, and then minus x1, which is a negative 3. And it's usually these negatives where students make mistakes. You're always subtracting, and it just happens to be a negative in this particular scenario, and that's why it turns into addition. It's never going to be addition naturally. You always have to think of that you're doing the change, which means you are subtracting. Emphasize that because it is a spot where students make a lot of mistakes. So this is going to be 6 in the numerator. 6 plus 3 is 9 in the denominator. And 6/9 reduces to 2/3, and that is equal to our slope. So that's a lot of the battle, but now we still need to figure out our y-intercept, and we don't actually know what that is. I imagine it's a negative based upon my graph, but if you're not given a graph and just given the statement, you're not going to know that off the top of your head. So now that we have the slope, we don't have any 2 points that we could use, so we go back to what we just did and find the equation from a slope and a point. So I'm going to use my y equals mx plus b equation and plug my slope right in there. So 2/3 is going to go in for my slope because I just calculated that. So I now have y equals 2/3 x plus b. And now I can plug in either one of these points into my equation. Plug in this one or that one. It doesn't matter which point you choose. You're just going to choose one of them and you're going to plug it in. So if I choose the point 6, 1, That means that 1 is going to go in for y, and that's equal to my slope, which I calculated already, which is 2/3, and that's multiplied by 6, and then plus b. And then you simplify and solve for b just like we did previously. 6 times 2/3 is going to be equal to 4, so you have 1 equals 4 plus b. You subtract, and so you get b equals a -3. This equation is then y equals 2/3 x minus 3. And that's how you find the equation of a line through 2 points. You find your slope first through those 2 points, being careful with subtraction. Then you take that slope, plug it into your formula,